Welcome to The Cosmic Codex, exploring our science fiction universe. With science fiction author Brian Scott Pauls. AI voiceover created using Mike Monster.
Hello, everyone. I'm Brian. This is the Cosmic Codex podcast episode for Friday, August 14, 2026. So, in an effort to catch up from my long absence, I'm going back to reply to some comments readers left on my articles. And back in July, Lawrence T. Gurley responded to my article, Must Read Books Acquires Analog Asimovs and F&SF. He describes himself as an 85-year-old retired college teacher and ex-aerospace engineer. He says, when I started high school in 1950, the Bronx High School of Science at the old Creston building near the Grand Concourse, there was a used bookstore across the street that seemed to be liquidating someone's collection of astounding science fiction going back to 1938. I think I bought the whole collection 1 or 2 episodes at a time. When I left home for grad school in 1957, my mother sold my astounding Galaxy F&SF. I eventually forgave her. Lawrence, thanks so much for commenting and for forgiving your mom. It's important to forgive people in our lives, even when they do us wrong. I mentioned in my response to you online that you almost certainly overlapped with Samuel R. Delaney at Bronx High School of Science, but I checked the dates before this episode, and it looks like you missed one another by a couple of years or so. In any case, I appreciate having you in my audience. It's an honor. If anyone else would like to leave a comment, go to thecosmiccodex.com, sign up for a free subscription, and leave your thoughts on one of my articles. I'd love to respond to you. So, why don't we see equal amounts of matter and antimatter in our universe? The ledger of particle physics just doesn't balance. The Big Bang should have created matter and antimatter in precisely equal amounts, which should have mutually annihilated on contact, leaving nothing in the universe but radiation, basically light. Yet here we are asking why. For approximately every billion matter-antimatter annihilations, one particle of matter survived. This matter made the stars, planets, nebula, and us. Physicists call this the baryon asymmetry problem, and it's one of the greatest unresolved mysteries of science. Now, science fiction has been playing with antimatter for nearly a century, but mostly for fun reasons like fuel and firepower. Jack Williamson's CT series puts antimatter asteroids in the belt and sets engineers to taming them as fuel for spacecraft and power plants. E. Smith weaponizes antimatter as the negasphere, a bomb of negative matter, or antimatter, in Gray Lensman. Some authors have written stories skirting the central mystery of baryon asymmetry, but none seem to have tackled it directly. One quick reminder. Cloudacy, my consulting business providing fractional chief technology officer services, is now a sponsor of this newsletter. If you or someone you know needs professional tech guidance for your author, coaching, or independent publishing business, check out the link in the show notes. Thank you. The simplest solution to the mystery of the baryon asymmetry problem is to deny it exists. Perhaps the universe is balanced, and the antimatter is simply somewhere else. This was a respectable scientific position for much of the 20th century. Antimatter atoms would form antimatter planets, stars, and galaxies. From a distance, we wouldn't be able to tell the difference, because light emitted from an antimatter atom is identical to light emitted from a matter atom. Larry Niven's 1967 story Flatlander is an SF treatment of this idea. Beowulf Schaefer investigates a rogue planet inbound from intergalactic space, and it's an object so strange and lethal that the mystery of its true nature drives the plot. Of course, it's made of antimatter. This planet is a relic from the universe's missing half, preserved for billions of years only because it stayed in the void between galaxies, where there was nothing to touch. The hiding hypothesis hasn't aged well. If any substantial region of the universe were made of antimatter, gamma radiation from the annihilation of gas particles would light up its boundary with neighboring matter regions. Astronomers have looked. The sky shows no such signs out to distances comparable to the entire observable universe. Experiments like the Alpha Magnetic Spectrometer, AMS-02, aboard the International Space Station have hunted, so far without confirmed success, for even a single heavy antinucleus, such as one atom of antihelium, that could only have come from an antimatter star. Something very early on treated matter and antimatter differently. In 1967, the Soviet physicist Andrei Sakharov worked out what that something would require. To cook a matter surplus from balanced ingredients, the universe must satisfy three conditions. First, a way for baryon number to change. Some process must be able to create matter without creating an equal amount of antimatter. Two, violations of two symmetries called C and CP. The laws of physics must, at some level, distinguish between particles and their mirror image antiparticles. And three, a departure from thermal equilibrium, a moment of rapid one-way change, such as the first fraction of a second after the Big Bang, when reactions couldn't run backwards and erase the surplus as fast as it accumulated. It turns out our universe does satisfy these conditions, just not enough. The second condition made headlines when CP violation showed up in the laboratory. Physicists first caught nature favoring matter over antimatter in the decays of kaons in 1964, then in B mesons at the turn of the century. In 2025, the LHCb experiment at CERN added a long-sought piece, the first observation of CP violations in baryons, the family of particles that includes the protons and neutrons we're made of, measuring a small but unmistakable difference in how a particle called the beauty lambda and its antiparticle decay. But when we add up all the CP violation the standard model provides, we fall short of the observed cosmic surplus by many orders of magnitude. Something else, perhaps new particles or forces, did the real work. One possibility is a scenario called leptogenesis, in which an early small asymmetry among neutrinos converted into the baryon asymmetry we see today. Experiments now under construction, like the Dune Neutrino Observatory, are designed to hunt for it. Meanwhile, researchers at CERN have begun interrogating antimatter directly. In 2023, the Alpha G experiment dropped antihydrogen atoms and confirmed that they fall down, not up, closing off one exotic loophole. There's a stranger way to think about the missing antimatter, and it comes from one of the most elegant ideas in physics. In the mathematics of quantum field theory, the Feynman-Stuckelberg interpretation, an antiparticle is indistinguishable from an ordinary particle traveling backward in time. A positron moving forward through time is an electron moving the other way. Seen through this lens, why is there more matter than antimatter becomes a question about time itself. Why does our region of the universe have a single, consistent arrow? Greg Egan has rigorously dramatized this connection in his orthogonal trilogy, culminating in The Arrows of Time. Egan builds an entire alternate cosmos, different geometry, different physics, worked out in loving detail, in which clusters of matter can carry opposed arrows of time and annihilate on contact. His alien civilization faces extinction from an oncoming swarm of such matter. In the final book, the characters visit a world where time runs the other way. Egan's characters confront their asymmetry the way our physicists confront ours, with arguments and experiments while recognizing our existence itself may depend on imbalance. In The New Cosmogony from the 1971 collection A Perfect Vacuum, Stanislaw Lem proposes what may be the most audacious answer of all. He frames it as a lecture delivered by a winner of the Nobel Prize in Physics. Its thesis is the laws of physics are not primordial. They are the accumulated moves of a game played over billions of years by civilizations so old they have stopped building things in the universe and they have started rebuilding the rules of the universe itself. The odd features of physics, lopsided constants, broken symmetries, are strategy, not accidents. Lem makes the sheer arbitrariness of physical law the central mystery of the plot. Faced with the problem of baryon asymmetry, his Nobel laureate might smile and tell us it's just another move in the game, a fascinating spin on the fine-tuning argument. Antimatter isn't the only thing missing. There's a surprising lack of science fiction stories in which baryon asymmetry is the mystery to be solved. Consider these possibilities. The audit. A physicist finally derives the baryon asymmetry from first principles, and the derivation works only if someone chose the number. Saganite encoding in the digits of the surplus holds a message, the universe's terms of service, left by whomever determined the asymmetry. Now the question is, should we acknowledge receipt of the message? Past due. Leptogenesis was real, but it wasn't natural. A late universe civilization discovers that the primordial antimatter wasn't destroyed, it was borrowed against. Its share of existence deferred to keep the ledger balanced. Now the deferred half is due, and the collectors experience time in the opposite direction, remembering our future, negotiating in reverse toward a settlement that must conclude at the Big Bang. The last anti-star. An interstellar probe finds a single ancient antimatter star shepherded through the void for 13 billion years inside a containment structure. Is it a museum, a cosmic seed vault, or a witness under protection? Why has it been preserved, and for whom? We may learn tomorrow why matter won, or the answer may wait, buried in neutrino data or physics we haven't yet discovered, for a century or more. Either way, the missing half of the universe is more than just an accounting problem. It's a fundamental piece of the puzzle, inherent in the question, how did we get here? Thanks for listening, everyone. If you enjoy discussing award-winning writers and science fiction, join me in Club Codex. This month, I'm reading and commenting on Arboreality by Rebecca Campbell, winner of the Ursula K. Le Guin Prize for Fiction. Go to the Cosmic Codex at thecosmiccodex.com, sign up for a free subscription, and scroll to the section of the current article where I discuss our present Club Codex selection, just following the article text. Click the discussion thread button to follow along and participate. And don't forget to leave a comment on today's article. Have a great week.
Artificial intelligence tools performed multiple tasks in the creation and publication of this podcast. Please share your thoughts about this episode by commenting online in the original article at thecosmiccodex.com. You can also find source links in the online text. Don't miss an article. Subscribe today to the Cosmic Codex email newsletter at thecosmiccodex.com. Thank you for listening.